Welcome to the video lesson over problem 1. So as usual, you want to make sure that you are recording your notes down. So you have Unit 4B, Lesson 1, Unknown Exponents. And today's focus is that we can write an exponential equation to solve for an unknown exponent. All right, so the example that we had in the problem in the first pre-assessment or the check your readiness assessment is the situation here where it says, in a lab, a colony of 100 bacteria is placed on a petri dish. The population triples every hour. Okay, so a couple key things here are that we want to highlight that it says 100 bacteria is placed on a petri dish. And I think in your problem it says initially placed. And then it says it's followed by triples every hour. Okay, so here we want to write our equation. Okay, and so we're going to write this as P of H is equal to 100 times 3 to the H power. Okay, and so remember H represents our number of hours, and P of H just represents the notation for output. And the output in this case is going to be the number or the population of bacteria. So population of bacteria. Okay, so also just to recall, like 100 represents our initial value, and 3 represents our growth factor, okay, which was given in the problem. Cool. So once we have all of those parts, all we have to do is use this equation to solve for each of these different points of the hours. So we can go ahead and write, let's see, I'm going to write P of H. Well, in this case, it's actually going to be, our input's going to be 4. So we're going to write 4 in here in a second. So P of 4 will equal 100 times 3 to the 4th power. So we're going to plug in 4 in here and 4 up here. And once we do that, we type this into our calculator. And so we're going to say P of 4 is equal to 81,000 bacteria. So this is the same thing as 100 times 3 times 3 times 3 times 3. Okay, which will equal 81,000. All right, so we can say when there's, in 4 hours, there'll be 81,000 bacteria. Okay, and then moving on to the next problem, we do the same thing, right? We write our equation the same way, but this time we're going to write 90 minutes, right? So this is in minutes, and we want to represent our equation in hours. So that's equivalent to 1.5 hours. All right, so we're going to plug in here 1.5, and at the top, let me go ahead and erase that. At the top for our exponent, we're going to write 1.5. Now, remember that we talked about rational exponents in our previous lessons. So here we can write 1.5 as 3 over 2, right, which is equivalent to the same thing as 100 times 3 with the square root, right, of the square root of 3 to the 3rd power, right? So another way to just rewrite all of this stuff is to make sure that you can use all of the previous knowledge that we've talked about. But either way, these are all the same, and these are all the same expressions. So if you type any of these expressions into your calculator, you're going to get the same answer. So we're going to say P of 1.5 is equal to, so if you type in any of these into your calculator, you're going to get 519.62 bacteria. Okay, and so that would have been your answer rounded to the nearest hundredth. And so moving on to our last example here, half an hour, well, that's already in hours, so we just have to write 1/2 as our input, which will equal 100 times 3 to the 1/2 power, right? And so again, this will equal the same thing, forgot to write my equal sign. This will equal the same thing as 100 times the square root of 3, and putting the 2 over here and the 1 over here. So it's the same thing as 100 times the square root of 3. Again, any of these expressions will give you the same answer. And we can write p to the 1/2, or p, when our input is 1/2, then our final answer is going to be 173.21 bacteria. Okay, well, so these are the answers that you should have entered into your check for readiness. If not, now you know. And that's it for that first part. Now, moving on to the second one. So here it says, estimate or find the number of hours it would take the population to grow to 2,700 bacteria, followed by 1,000 bacteria. Okay, well, first things first, let's write our equation one more time. So P of H equals 100 times 3 to the H power. This time, we want to figure out right, the number of hours. So that's a clue to tell us that our input that we need to find out should be H, okay? So we wanna we know that's our variable. So in this case, we're gonna go ahead and say that P of H, meaning the output, right? So this represents output, is given to us. We know it's 2,700. So we're gonna substitute in 2,700 in place of the whole entire P of H. So that's going to equal 100 times 3 to the H power. Now, how can we figure out what is the value of H? Okay, so you can actually just plug this into your calculator and figure out the values, right? So let's go ahead and do that so we can, let's figure this out together. Let me just get here. So let's go to Desmos. I like using Desmos scientific calculator. It's really helpful. You just go ahead and click on that, and it should populate a calculator. And you can also use this on your phone too. So we can go ahead and write 100 times 3, and let's just plug in some values. So in the first hour, there's going to be 300 bacteria. That's not what we want. We want 2,700, just like it says right here. So then we go ahead and plug in 100 times 3 raised to the second power. That's 900. Still not what we want. So we keep going. 3 raised to the third power. Cool, we have 2,700, very easy. So all we have to say here is H is equal to 3 hours, and that's our answer. Okay, that one's nice. Now this problem, 1,000 bacteria, this time, right, our equation's output is gonna equal something different. So let's make this green. We know this is gonna be represented as 1,000. There we go. So here we can write this is equal to 100 times 3 to the H power. Okay, so let's say that we typed this into our calculator, which we did already, 1, 2, and 3, right? So that doesn't equal, and none of those values equal 1,000, so we have to find something in between. So we can tell that 1,000 is between 900 and 2,700. So we know it's somewhere between the exponent of 2 and 3, somewhere between 2 and 3 hours. So let's see what happens if we plug it in. So let's do 3 raised to like 2.1, right? That's pretty close, right? 1,004, but let's see if we can figure out something closer. So if we do it raised to the 1 power, that doesn't help. So maybe something 0 raised to the 9th. Okay, that's a little low. Let's see if we do 9. Okay, that's even closer. So we keep going until we find a value that works. And the one that happens to work, if we were to go through this process, would be 2.096, and that's our answer. So here, H will equal 2.096 hours for this problem. Okay. Now there is a faster or a cooler way, I think, using the second strategy. So over here, strategy 1 is to substitute with a calculator, which is what we did. Strategy 2 is to use Desmos and graph. So if we go ahead and you go to Desmos actual graphing, so desmos.com, and start graphing. Now we can go ahead and graph. If you're going to do this, you're going to have to do both 2 equations. You're going to write P of H, you always write your original equation, times 3 raised to the H power, right? And so we'll get an answer. we're going to adjust this. I'm going to adjust the x-axis to be from -5 to 10, and then this one is going to go all the way to, let me think about this, maybe 8,000. And then this is fine. Okay, so then once you have your equation, like that's our graph, as we can clearly see it's an exponential equation, the population growth. Now, when we want to find out for a specific time for a specific population, whatever the output is, so like 2,700 and 1,000, we're just going to do a different equation where it's y equals that number. So 2,700, right? And then also y equals 1,000. Right? And so where they intersect, where the red and those other two equations intersect is our answer, right? So we can see here in 3 hours, it's going to be a population of 2,700. And then here at 2 hours and 0.096 hours, or 2.096 hours, it's going to be 1,000, right? So this is another way for you all to figure out how many hours it takes for a specific population. So just for the fun of it, if we want to figure out like for 2,000, for example, or 2,000, right, we can see here it will take about 2.727 hours for the population to reach 2,000, right? And then also even smaller, like we can do 500, right? And it takes about 1.465 hours, okay? So, cool. That's it. So by the end of this video, you should be able to use an exponential function to find unknown exponents in context using different strategies, such as substitution and graphing. And that's it.